Section 7.3, example 3, is the integral of 1 over x squared plus 1 in parentheses to the 3/2 power. So it looks pretty simple, but turns out it's not something we can just evaluate right away. You may want to look at the exam 1 formula sheet, just verify we don't have an integral of this form that is given. Substitution maybe is helpful. A choice for trying to look at substitution would be a u of x squared plus 1 inside of the composite function. Again, it's not always that, but a lot of times it is. Your du is 2x dx. There's not an x hanging out there. You could multiply by x over x to introduce that, but then you'd have to represent the x down low in terms of u. Even if you could do it, it turns out, which you can, it's getting kind of complicated, and then that resulting integral is not something that you can evaluate, so it doesn't help you. So we can't do substitution, which means we got to look for other options. Turns out we got a square root in disguise here. We got a rational power of 3/2, and the 1/2 part is the same as the square root. So you should be looking at trig sub and see the form there that would be applicable to this. So that's going on to step 2, that this is the form, a little bit in disguise, of the root of x squared plus a squared, where our a in this one is going to be 1. So again, on the formula sheet for exam 1, you're told that the substitution you should make is x is equal to a tangent theta, where a is 1, so this is going to reduce down to just tangent of theta. One of the next steps is you're going to have to find dx. We're going to plug everything in terms of theta into our integral. So if you want to do that here, because you're right next to your x substitution, that would be fine. So taking the derivative of x with respect to theta is secant of theta squared. And then multiply both sides by d theta, and you have dx equals secant squared d theta. So now we're ready to move on to what I've defined as step 3, and again, you don't have to show these steps on your homework. I just have it for you in the notes and stuff so that you can see it broken down in their long problems, so you can just see where I'm at in the process. I'm going to write the original integral. It's already off the screen here. We got our integral, we have dx on the top, and then parentheses x squared plus 1 to 3/2 down low. Alright, so now what we're going to do is put this in terms of theta by doing the substitution for dx, and then our x, anywhere we see that, we just got 1, we're going to put it in tangent theta. So doing that, I have secant of theta squared on the top times d theta, and then careful here, it's the x we're putting in the tangent theta for, so it's going to be grouping symbols, another set of grouping symbols, tangent of theta squared plus 1, close up the outer parentheses, and then we have a power 3/2. Alright, now this is supposed to help us, and we're looking at it, and maybe it's not obvious. Step 4 does not have to be done at this stage, but I put it here because sometimes people get stuck here. For these problems all the time, what's going to happen is you're going to be able to use one of the Pythagorean identities in order to help you simplify this and get on the road to evaluating that integral in terms of theta. So because we have secant and tangent stuff, the one that's going to apply here is secant squared minus tangent squared equals 1. And so didn't introduce that here, so I'm going to use this. I'll just put that as an afterthought. And it's going to apply to the root, which is the part that's down low. So step 5 is to simplify with that trig identity in mind. And that root is the thing that really needs to simplify for this to happen, for the good things to happen here, so that we can evaluate this integral. So we'll focus down there. Notice that we're going to be using this trig identity right away because we have tangent of theta squared plus 1 some side work if necessary to see what the substitution is going to be. I can write my identity in its original form, and then can I do algebra to get tangent squared plus 1? And I can by just simply adding tangent squared to both sides. So we can make the substitution of secant squared for 1 plus tangent squared. In this next step, I'm just going to show that plugged in here. Overall, we have secant squared theta, or I should say secant of theta squared, and then we have secant squared to the 3/2 power now. So here's where the magic happens, or maybe not magic, but the good algebra that's going to make things roll along here and be on a good path to our evaluation of this integral in terms of theta. Simplifying the bottom, the square and the root, or the power 1/2, undo each other. So doing that simplification, we get secant to the 3rd power. We got secant squared hanging up top, so we get some major canceling here to just have 1 over secant. So this is the simplifying part. And you take a look at this and you say, do I know how to do this integral now? And it might take some manipulation. I have a 1 over secant, which is not simplified. So that's a hint that maybe I should do another step here and see what that would be. So secant is equivalent to 1 over cosine. 1 over quantity 1 over cosine is just simply cosine. And then bells should be going off in your head that this is, we can do this, we're almost done. Integral of cosine is sine. Attach your plus c. And we're almost done here. We evaluated the integral, but the original integral was in terms of x. We introduced this trig substitution. We evaluated the integral, and it's in terms of theta. So we got to get it in terms of x. Next thing is to work on that. I'm running out of room here, so I'll kind of put it off to the side here. This is going to involve going back and thinking about what your original substitution was. Ours was x is equal to tangent theta. We're going to do that triangle thing. I could put this x over 1 to get a fraction, and then I need to remember that tangent in right triangle land is going to be opposite over adjacent. So if I have x over 1, opposite is going to be, edge is going to be x, and the adjacent one is going to be 1. Finding the length of the hypotenuse then is going to be 1 squared, or 1 plus x squared root of that. Go back to your original answer here, and you should be able to use this to write your total answer. So the sine of theta is just going to be opposite over hypotenuse, which is x over, plus c. It's just going to be x over the root of 1 plus x squared plus c, and you're done.